and welcome to our video on exponential and logarithmic functions. This video will focus on index laws. Now when we have a index written out, and I'm just copying this one from here, we end up with a to the m, and just a reminder, the big number, the a in this example, is the base, and this little number is the power, but it's also known as all these other numbers, all these other, sorry, not numbers, all these other words as well, or terms. The m can be called the power, the index, the exponent, or the logarithm, and this one will be really useful for what we're doing when we do our logarithmic functions later on in this unit. The definition I've got here is a base to the power m means the base written out and multiplied as many times as you have the little m there. So if it's a to the power 2, then you've got 2 a's written out. If it's a to the power 100, you'll have 100 of these a's written out. A needs to be an element of the real numbers, and m needs to be an element of the natural numbers. Index laws, quick revision on those. The first index law, if we have the same bases and we're multiplying, we can add the powers. Second law, if you have the same bases and you're dividing, you can subtract the powers. And another way of writing this one out is a to the m divided by a to the n. So you might see it looking like this in fraction form. Third law says a to the m all to the power n. So I like to say the indexes or the powers are touching, so you can multiply them together. If you have two bases, a and b, all to the power m, you can expand it out to make it the first base to the power m times the second base to the power m. And two identities we have at the end here, they're not really laws, but I've kind of put them on here to help you out. Anything to the power 0 equals 1, and the base cannot equal 0 for that to work. And anything to a negative power is the same as 1 over the same base to, you just changed it to a positive power. Okay, I've got some examples here. If you haven't done them yet, you might like to pause and have a go yourself, but if you're ready for the solutions, listen on. Okay, first example. We've got a times here, so I'm going to look at the first index law, which says when we're timesing by the same base, and they are in the same base, we can add the powers. So I'm going to end up with a to the 7 plus 3, which is 10, and a to the 4 plus 10, which is 14. And now I can use our second index law, which says we can subtract the powers when we're dividing with the same base. So I get a to the negative 4. And you'll see here in our question, it's asking us to express the answers with positive indices, and you always need to do that when you're simplifying your work. So this is a negative index or power, so we just need to rewrite it as 1 over a to the 4. Second example. First thing I've noticed is this 2 to the negative 1 on the denominator of the fraction, so I'm going to move that to the numerator, and I'll end up with, I'll keep the 5 in the numerator. The 2 will go on the top, so it'll be timesed. And I've got a to the 3, take away a to the negative 2, which will give me a to the 5. And b to the negative 7, take away 2. And I get b to the negative 9. So I'm just going to write that straight away on the bottom as a positive index. And we've got our solution. Example 3. First thing I'm going to do is get rid of these brackets. So everything in here needs to be squared. So start with the 4. 4 squared is 16. X squared to the power 2, so you times these powers together. X to the 4. Y to the negative 8 times 2. Y to the negative 6. Oh. (16) over negative 3 squared, which is 9. X to the 3 times 2 is 6. And y to the negative 3 times 2 is negative 6. When I simplify this, I'm going to end up with 16 on the top, and 9 will still be on the bottom. X to the 4 minus 6 is going to be negative 2, so I'll put that on the denominator. Negative 16 minus negative 6, so that's negative 16 plus 6, which is negative 10, so I'll put that on the bottom there. Example 4. I'm going to rewrite this as its lowest base, prime number base, so we can write 8 as 2 to the power 3 squared times 3 to the 3 times 2 to the negative 4, just leaving that similar up there. I can write 4 as 2 squared times 3 to negative 2 times 9. Oh, sorry, I'm going to rewrite that 9 as 3 squared. And I'll go across the page so I don't run out of room here. End up with 2 to the 6 times 3 to the 3 times 3 squared over 2 to the 4, 2 to the 4, 3 squared. And when I simplify all of this down, I end up with 3 cubed over 2 squared. And you could leave it like this in its simplest form, or you could put this into full numbers and end up with 27 over 4. Either answer would be fine there. Example 5. I've got division of two fractions. So using my fraction rules, I can flip the second fraction and multiply. So I will start by simplifying the first one as much as I can. And I end up with 3 over 8 c cubed d. Now I'm going to multiply. And all in one go, I'm going to flip this upside down and cube it. So whatever's on the denominator here will go onto my numerator here. 2 cubed is going to be 8. C4 times 3 is 12. D to the 15 over whatever's here, 3 to the power 3, which is 27. C cubed D, sorry, right, D cubed, D to the 9. Equals, this first one's going to stay the same for now. Simplify this one a little bit. 12 minus 3 is 9. 15 minus 9 is 6. And we're left with 27 on the denominator. Now I can use my fraction rules and multiply the numerators together, then multiply the denominators together. 3 times 8 is 24, and this whole bit will stay. Actually, what I'm going to do because I know this bit's going to be on the denominator, so I can go C, 9 take away 3, which is going to be 6, and D to the 5 over 8 times 27, which is 216. When I simplify this down further, I end up with C to the 6, D to the 5 over 9. Our final example here has lots of 2 to the m's in it. So when I look at this, I think, hang on, maybe I can simplify by taking out a common factor. So I'm going to try taking a 2 to the m out the front. 2 to the m times what makes 2 to the m? 1. That's easy. 2 to the m times what makes 2 to the m minus 1? So if you use your index laws, you'll find 2 to the m times 2 to the m, 2 to the m times 2 to the negative 1 will equal 2 to the m minus 1. Do the same on the denominator if I can, and I end up with 2 to the 1 take away 1. And now that I've got 2 to the m in the numerator and the denominator, I can cancel those two out. And I end up with this, which simplifies to this. 2 minus 1, which is 1. So it's going to equal 1.5, or 3 over 2 is what I meant to write. Thanks for watching the video.